Hi, Chris Good here, and I'm going to walk you through a problem like the one on our sample quiz where we've got a source table with only a couple of values given, and you need to fill in the rest of the table. This is actually kind of an easy problem to solve, but you have to know how to do it. There's kind of a little bit of a trick to it. So let's get started. This is a source table, an incomplete one, and a source table is something that you'll find a lot of times when you do an analysis of variance in, say, a computer program like SPSS, or if the computer's calculating your analysis of variance for you. It tells you the source of variability, and in the case of an independent groups analysis of variance, we've only got three total sources. So between treatments variability, within treatments variability, and total variability. So that can be expressed in the sum of squares. It can be expressed in the mean square, and those degrees of freedom you use to compute the mean square are often given in the table too. Now, tables will also give you the calculated value for f, and those are really the only two values we're given here in this fill-in-the-blank source table problem. We got sum of squares within treatments and f, and that's all that we're given. However, the description of the study gives us enough information to fill in at least a couple other values on this table, and that's really all that we need to complete the rest of it, given that you know the equation. So if you look at the equation for f, it's the ratio of this mean square to this mean square here, between treatments over within treatments. That's what equals this f. So if we can find one of these, then we should be able to find the other one given what f is. So the question on the quiz gives you some more information. First of all, it says, and this is off screen so you can't see this, but check out the sample quiz that I've given you. A researcher used an analysis of variance to compare 4 treatment conditions with a separate sample of n equals 9 participants in each treatment. Okay, so we already know what the degrees of freedom are between treatments. If you know that there's 4 treatment conditions, you know that between treatments degrees of freedom is that number minus 1. It's k, the number of treatment conditions, minus 1. So just moving that off screen, and we're going to put that in here for degrees of freedom between treatments. It's k, which is 4 treatment conditions, minus 1. That's how we get 3. Alright? You should also be able to get degrees of freedom within treatments as well. I said that there were 9 participants, 9 subjects in each treatment. There were 4 total treatments. So if there are 9 scores in each treatment, and there's 4 scores, and that's 9 times 4 are 36 total scores, right? 4 times 9. So 36 total scores. Well, if we knew that k was 4, how do we know that? Because there are 4 treatment conditions. And we know that n is 36, then you know degrees of freedom within treatments, because that's big N minus k. 36 minus 4 equals 32. Okay, now we're getting somewhere. If you know sums of squares and degrees of freedom, then you know mean square. So we have within treatment sum of squares and degrees of freedom. So we can get mean square by dividing. That's equal to the sum of squares divided by the degrees of freedom. You can do that on your calculator. Excel does it for you, but that's how we calculated the mean square for within treatments. Well, now we need to work backwards. Okay, if you know this mean square, let's get our formula back up here. If you know the within treatments mean square, and you know f, then you can get the mean square between treatments by just multiplying both sides by the mean square within. Alright, so this is 2.5, that's f. This is 2.0625. So we should be able to find the mean square between treatments should be f times within. F times within mean square. So the mean square between is equal to f times the within treatments. Oops, I'm sorry. That's not a value. It's 2.5. That's what F is. Okay. Let's think about how we got that exactly. All right. So we know F. Right? That's equal to 2.5. And that F is computed by MS between treatments, which we don't know, divided by MS within treatments, which we do know. I just calculated that. Is 2.0625. So if we know that this quantity here is equal to this quantity, how do we get this top part by itself? Well, I'm just going to multiply, I'm going to use the symbol, I'm just going to multiply 2.0625, right? And do this on both sides. It goes on this side of the equation, goes on that side of the equation. And when we do that, these two cancel out, right? And there you go. It's MS between treatments is equal to the product of F times MS within treatments. Okay. Well, we can still fill in the rest of the, even though we know F, well, we started with F. We want to fill in all the information we possibly can. The between treatments sum of square, right? Let's remember that sum of square, the mean square between treatments, which we know, is equal to sum of squares between treatments divided by degrees of freedom between treatments. Well, we're going to do a similar thing here, right? That's going to be equal to, right, sum of squares between treatments, which we don't know, divided by degrees of freedom between treatments, which we do know. And that's equal to this quantity here. That's equal to mean squared between treatments. Well, we just calculated that. That's equal to 5.15625. Okay. Same deal. We're going to multiply both sides of this by 3. Right? These two cancel out. And we get sum of squares between treatments is equal to 3 times 5.1625. Or this is equal to this times this. Well, there's only a couple of more things to fill in. Remember, your total sum of squares is always going to be equal to the sum of between treatments sum of squares and within treatments sum of squares. ANOVA is analysis of variance, splitting variance, and we split this total variance into these two parts, right? Degrees of freedom sum the same way, right? The total degrees of freedom is equal to the between treatments degrees of freedom plus within treatments degrees of freedom. There we go. So that's 35, and that's the entire table. That's what we wanted to know. You should find that this total degrees of freedom is equal to the number of scores you have minus 1, and it is. And that this 2.5, right, is equal to the mean square between treatments divided by the mean squared within treatments. And indeed, it is exactly. That's how you fill out a source table. Remember, we only started that with sum of squares within and F. That's all we knew. That and 9 scores in each of 4 treatments. Right? We were able to get everything else starting from there. So it really helps to look at that formula sheet while you're working through. And the big hint, how do you solve this on the test? Start with the degrees of freedom. You should always know these based on the information about the study. All right, good luck, and we'll see you next time.